Up to now, everything has been simplified a little bit. I always say I never lie to my students. I sometimes don't tell them all the truth at once. You kind of got to build, and you got to build, and you got to build. We said oxygen's number 8 because it always has 8 of what? And it still will. That is true. And that will always, always, always be true. That won't change. We said protons have what kind of charge? Protons? Positive charge. And that will never change. That is true, true, true.
I thought you was trying to trick me there.
Not yet.
I didn't try it.
Not yet. I have warned you.
I have warned you.
Now, because oxygen has 8 positive protons, it makes sense that when it was made in the beginning, it should have 8 negative electrons also. Okay, and that's true. To start with, oxygen will have 8 positive protons, and it will always keep them. And oxygen will start with 8 negative electrons, and it will not always keep them. We're about to get into why atoms bond. We're going to get into why is it H2O and not H3O or HO2. There's a reason they bond in certain patterns, and it has to do with that electron. It's all about electrons. And it all goes back to the good old periodic table. Now, we talked about Mendeleev. He put them in order, and when he put them in order, what happened? Why did 1 and 3 and 11 and 19 all end up in the same column? A little louder.
They all react to almost the same.
Yeah, yeah. And what name have we given this first column? Okay, they all have their, you're ahead of me a little bit, young man. That's great. Can you hold that answer just a little bit?
Yeah.
Okay. I want the name of just the first column. They're what kind of metals? I hear it louder. Alkali. Alkali metals. That's a name you now give them. And I'll be super impressed if you name me the second column's name. It's a lot like alkali metals. I got it? Alkali earth metals. Great job, folks. Alkaline earth metals. So those are some names. And early in the year when you first looked at the periodic table, you said, man, why is there a brown row and a purple row and a pink row? Now you know. They call them families. And Will, being the bright young man that he is, he says, it's all about, what are you laughing at? It's all about their electrons, isn't it, Will? The reason they act alike is because all of these have their last electron in the what block? S block. These are all in the S block. They are all in the S block. Where'd you get? Where'd you get? So when you came to choices like, who acts most like Na? Well, this was really blurry. There is Na. And your choices were Li right above it or C over here. And of course you went with, yeah, it's in the same column. And in the second case, that's C. Ar, whoa, Ar is there. Al is in the same row. He's in the same column, and we always go with columns. Columns are more important than rows. Great, great. It's all about their electrons, isn't it? Thank you. Now, on this page, we used a brand new word called valence electrons. It's going to be really important in the next couple of weeks. The valence one are the last ones. The last ones. You know, the example was if you took sodium and you did the old green sheet, down and up and up and up and up, all those steps, it took all that. But what we figured out is, when it comes to what does sodium do, how does it react, it's all about the last one. And so we use the term valence for the last one. Okay, we said alkali metals, and they are violently react with water, of all things, with water. They violently, that's a pretty good reaction with water, isn't it?
Oh yeah. Finally.
Okay. Now we keep going around, and we could do all the families on the periodic table, but we didn't. You looked at the alkali metals, they reacted real fast. You looked at the alkali earth metals, they reacted. And then I had you jump to the far right side of the periodic table. In the middle, what's that big group in the middle? All these red,
Aren't they metals?
and what kind? Remember the word for them? Transition. And the transition means to make a switch. Make a switch. So on the left-hand side, we had super strong metals. Over here, we're going to have non-metals. And as we go across, Jalen says, we make a transition. So things like copper and lead and gold and silver and things that you normally think of when you think of metals are in that middle group. And then some other weird things like iridium and goldenium and things like that. So that's the transition. And next, we jump clear to the far right-hand column. And what was their name? What kind of gases?
Noble gas.
Noble. What's noble mean? What's nobility?
Smart.
United States, we don't have nobles. Europe. England still has nobles. Who are they? Who's the Queen of England?
Elizabeth?
Yeah, Queen Elizabeth, that little old white-haired lady, right? Okay. All right, and her son is Prince Charles, who was married to Di, and we all know that whole terrible story. And they have two kids, and one of the kids got married, right? Harry the one got married? The other one got married. Oh, come on, you're not following this whole story? And what about his wife?
His wife
Is now
is now like a
pregnant. Yeah, she's now pregnant. It's a whole big story. If we were in England, we'd all be talking about. So once again, they are the nobility. They are the upper top. They are the kings and queens and princes and princesses and dukes and things. All right? And all the rest of the people, just common, ordinary people like us. So noble means, in the old days, kind of snotty old people, the aristocrats who thought they were too good to mix with the other people. Now, the noble gases, what is interesting, do not react. If I had a balloon full of hydrogen, it would explode. That's what happened to the Hindenburg. If I had a balloon full of helium and lit a match under it, what would happen? Nothing. Because it does not react. So guess what they put in the Goodyear blimp? They don't fill it full of hydrogen anymore, they fill it full of helium. It's safer. It will not catch on fire. You can't make it explode. It does not react. And the more sciencey word for that is inert. I'm inert. I don't want to react. The reason they're called noble gases is because stuck up. Now, don't want any names, but you know some people who like are too good to be your friend. Just leave me alone. I'm perfect the way I am. Don't name any names. That's kind of like that's why they call them noble gases. They will not react. They will not react. You can't be my friend. I won't let you be my friend. I'm a noble gas. All right.
That's not even right.
So, if you're writing a chemical equation, will you expect to find any of these dark purple symbols in it? No. They're going to be just themselves, and they will not mess around with anybody else. They're not that kind of element. And then I had you look at one more group called the halogens, which were one step in from the right. They were the brown ones, fluorine, chlorine, bromine, iodine, etc. They also are very reactive, but they're the opposite kind of reactors to with what we just saw. We saw the alkali metals, and if I put them with water, who did the alkali metals take and bond with? Did they take the oxygens, or did they take the hydrogens? They took the oxygens, and they left the hydrogen alone. But if you go to the other side of the periodic table, the next to last column, this group, if you put them with water, would also react violently, but they would grab the hydrogens. They grab the other part. Now the reason I don't is because dangerous property, chlorine, fluorine, bromine. I recall that, what's dangerous about them? They're poisonous gases.
Oh.
Okay? Chlorine gas. World War I, they used called mustard gas. It's chlorine gas and things like that. And we banned the use of it. The name is mustard gas because it's kind of yellowish, but it really was made out of chlorine. All right, why do you, go ahead. Oh yeah, very deadly, so I won't bring any into the room. Okay? No reactions giving that off. Now, here's my question. Chlorine is one of these noble gases. What's a common use of chlorine? All right, what do you put it in the pool for? Cleans it how? You're right. Kills the algae. You algae killer. Because chlorine's poisonous. Oh my gosh. So when I open my eyes underwater, why is my eyes burning? Because the chlorine is,
That's
yeah.
all.
And then when you get
Ah,
out
it's
of
kind
your
of
eyes.
good, yeah. All right. Don't drink too much. Once again, you put it enough, and there's always all the ingredients, put so much in the water, etc. You don't want too much. You don't want too much. It'll start, your skin will start turning white and flaking off. It starts killing you from the outside in. Okay, what else we use chlorine in? Chlorine bleach. What's the chlorine bleach do? Kills the germs, doesn't it? All right, so things in this column are poisonous. Iodine. What do you use iodine for? Sometimes medicinally.
Oh, I forget.
Talked about that, didn't we? I got a cut, so I put some iodine on it. What's the iodine do? Kills the germs. It burns you, yeah, but it's killing the germs too. So iodine's poisonous, so you put it in a little spot to kill those germs right there. As long as you don't have too much of it, you'd be okay. Sir? No? Sure? Alrighty. So, bonds are like two people holding hands. Bonds are like playing Red Rover, we dare Brian over. Two atoms hold on to each other. And we say, well, this paper is bonded together. What's holding it together? The atoms are holding on to each other. I got millions of atoms holding on to each other so it doesn't fall apart, does it? But if I like do this, why is that possible? Am I trying to,
Because there's, it ends right there.
and I'm just breaking
The edge, whatever.
one bond at a time, aren't I? You're right, you're right. It's the old trick about the phone books, I'm making rip those great big massive ones apart. They bend them so that they're only starting to tear a page at a time, exactly, okay. And they're trying to do what with their electrons? Make them stable was the word you just read about. Stable is going to be a key term here. All right, if you would please, on that sheet of notebook paper, this looks like it's going to be number 50. I don't need your name on it, number 50. If you start this. So, here we go. Molecular formula. H2O is a molecular formula.
So, it shows
And what does it show us? Two things. One thing, Johnny? One thing it shows us.
I don't know. You
Yeah.
talking about the experiment and everything?
What does this formula
Right there, show us?
Water.
Yeah. It is a formula for water. And what does it tell us? One thing, Kyle, about water. It tells us,
For every molecule, there's 2 hydrogen.
so it tells us something about numbers. So I'm going to say the amount of each element. Basically, I think that's what you're saying. For each one oxygen, I have 2 hydrogens. Thank you. And what's the other?
Oh, he said that.
Well, actually more obvious, I think, more obvious thing it tells us. Oh yeah, the types of elements and the amount of each element. So I'll give you a moment. How did McKenna astutely decide there were 3 different kinds of elements? Because she said there are,
3 letters.
well, what's special about those letters? The number of capital. Because what if I did this to you? Just made that up. That's not a real element. But the question is, how many different elements are there? There's just 2, because there's, even though there are 4 letters, the A goes with the C, the other A goes with the N, so there's just 2 different kinds of elements, aren't there? So the number of different elements is equal to the number of capital letters. Capital letters. The little number after it is called a subscript because it's below. Sub means below. What did we call the numbers up here when we did, yeah, when did we do those things? I forget what we used them for. Electron configuration, superscripts. Down here, okay, down here, there's subscripts. Subscripts. That 2 then is referred to as a subscript. They're always below, they're always to the right. It's not even while writing this down. Of that element you have. It only goes with this symbol immediately. What would the word fit in there if we wanted you to write it down? It goes with the L symbol after. So the question is the 2 going with the H's or is the 2 going with the O's? Is the real question, isn't it? It is. So what word would appropriately fit in here?
Hydrogen.
Oh, in the middle.
I'm sorry.
The symbol's immediately in front of the subscript, isn't it?
Of the line, front line.
All right. There is no subscript here, ladies and gentlemen, with oxygen. What's that mean about it? There's no oxygens? There's no symbol? There's no number? It really means there's 1, doesn't it?
It's kind of like algebra.
Because would I bother writing that O if there weren't any O's? No. So if there's none, symbols, formulas are a shortcut. You don't want to write, I have 1 oxygen bonded to 2 hydrogens. Do you? I don't. What I have in green is what that means. Wow, H2O. Boy, that's short. And I'm going to shorten it down so much I'm not going to even bother writing the O. So, this is what I want you to do on your paper. How many total atoms? You don't need to write the whole formula. I just want you to count the total, please. So we'll model this first before. Somebody said, Will, how many iodines are there?
2.
Okay. If I said, Johnny, how many yttriums are there?
3.
If I said, Dylan, how many uraniums are there?
7.
Thank you. So how many total atoms are there? That would be 12. That's all I want you to do. So, Miss Hannah, how many S's? Johnny, thank you. How many THs? There's not a 1 written there. Why not?
Because they don't need it.
I want to make it a shortcut. I want to make this as small as possible. I don't want to bother putting a 1. If there wasn't one TH, I wouldn't bother even putting a TH in there, is it?
But if there's more than one, obviously you'd have to put the number right.
Nicely said. Nicely said.
We should get a stick.
So there are 5 MGs, there are 7 platinums, and there are 12, and that came out to be 27. If you missed it, it was that stinker right there, wasn't it?
So close.
Okay, good.
26.
Once again, we're practicing a new skill. Maybe it's the first time you've done it. Some of you nailed it. Maybe you got lucky. Maybe you knew what you're doing. Some of you got it except for that missing 1. All right, down here, if you missed it, who was the troublemaker?
C1. Or C0.
That may confuse you. I got to quit using that. There's 1 CL. What else is the troublemaker?
MG.
There's 1 MG down there as well.